I'm going to show you the Laplace transformation of sine bt. So first we have to take the integral of e raised to negative st times the function sine bt dt from 0 to infinity. So to solve this, we have to use the integration by parts. So we will let u as sine bt and our du is cosine bt b cosine bt dt, and our dv is equals to e raised to negative st, and our v is negative 1 over s times e raised to negative st. So we will just use the integration by parts formula. So substitute sine bt times v, which is negative 1 over s times e raised to negative st, minus integration of negative 1 over s times e raised to negative st times our du, which is sine bt. This limits from 0 to infinity. 0 to infinity. So I will change the infinity. So sorry. The du is b cosine dt. Sorry for that. So I will change the infinity to a. So let's just assume that a is a very large number. So first we have to do this side. We will evaluate this. It will become sine bt, or we will substitute the limits. So sine b times a over s negative. I'll just simplified it. So e raised to negative s times a minus negative sine b 0 over s times e raised to negative s 0. So as we already know, e raised to negative very large number, it will become 0. So we will just cancel it out. So here, as you can see, it is sine 0. So the sine 0 is equals to 0. So this part is also cancelled out or equal to 0. So let's just focus on this part. So as you can see, we can extract or pull out our constant. So it will become positive b over s integration of e raised to negative st cosine bt dt. Pause. Okay. So sorry about that. So this will be solved by integration by parts. So we will let u cosine bt. So our du, which is the derivative of cosine bt, is equals to negative b sine bt dt, and our dv is equals to e raised to negative st, and our v is equals to negative 1 over s times e raised to negative st. So we will use the integration by parts again. So our formula, we will just use it. So our u is cosine bt times v which is negative 1 over s times e raised to negative st limits 0 to a, and minus our v minus integration of our v, which is negative 1 over s times e raised to negative st times our du, which is negative b sine bt dt. So we can also extract our constant here. So first I will solve this part. So I will simplify this part. So it will become cosine b times a over negative s times e raised to negative sa minus 1 over s times e raised to s times will become cosine b 0 over s times e raised to negative s times 0. So we already know that we will cancel it out. So negative times negative, it will become positive. And cosine 0 is equals to 1. And e raised to 0 is also equals to 1. So the remaining part is 1 over s. So now we can now extract our constant here. So it will become, and boom. So we will now extract the constant. So the positive b over s times the integration of e raised to negative st times sine bt dt. Now let's not forget the b over s on the outside. So you can see that this equation and this equation is the same. So we can just let the integration of e raised to negative st sine bt dt as y. So I will just write it here. So if we solve this, it will become v over s squared, and negative times positive will become negative. So it will become b squared times or over s squared, and this part will become y, as I said. So y, and this equals to y. So we can now transpose this part into the left side. So y plus b squared over s squared times y equals to b over s squared. So if we add this, it will become b squared plus s squared over s squared times y. So equals b over s squared. So if we simplify this equation, we will just cross multiply. So this will, or I can divide it both sides by b squared plus s squared over s squared, and divide this by b squared plus s squared over s squared. So this will cancel out. The remaining here is the y will remain, and here b squared over b over s squared divided by or times s squared over b squared plus s squared. So this will cancel times b over b squared plus s squared. So this y, you can replace it into this, which is also equals to Laplace of sin bt. So we can conclude that Laplace of sin bt is equal to this.